Hi everybody, my name is Lenny and welcome to the Flow Analytics Hub session at ICCX. First of all, I just want to say thank you to everybody that's joining. You could have done so many other things at this time, but you choose the time to spend it with us. So I just want to say thank you so much for that. What do I do here at Flow Software? Well, we all have got titles, but I like to think of myself as someone that provides contextualized information to operators, shift supervisors, executives, so that they can really trust the information and depend on the information to make informed decisions based on data that's collected from the plant floor and try to optimize their environment or their production. All right, so you might not have heard about Flow Software. So you might think, why does this product exist on the market? And really the cause or the things that we saw in the industry is that it's very difficult if I want to try and get this contextualized, trustworthy information to someone, actually to them, due to a number of reasons. We see that data is siloed. There's a whole bunch of different data sources on the industrial space, historians, batch databases, MES databases. And some of these might be very tough to access due to legacy protocols. One database might be missing context that sits in another data source. And I need to be able to get all of this together, but I might also sit with different formats. And how do I do that? And how do I actually then present something where I can actually make the best decision on what to do next without having the best information available? This is where Flow comes in. This is the dream that we're trying to achieve. And that dream is literally one place to serve contextualized data from these multiple data sources. Unified data that is accessible by everyone, that is trustworthy, and that is actually transformed already into the KPI that you need to make your decision on. So in essence, we want to be able to achieve or provide a proper analytics foundation that drives confident decision making to our audience that needs this information. Now, how do we do this? How does Flow achieve the dream? Well, we've got a 5 steps kind of building program that we go through to actually achieve this. And those 5 steps, very quickly, I'll go through them in a little bit more detail, is literally to go and model your KPIs, connect to all of these different data sources, transform the data, and perform calculations on top of that data to give you the KPI that you want to analyze. And then obviously we need to be able to visualize it to make sense of that information. And very importantly, we need to be open. We need to be able to bridge this information out to numerous ways for numerous consumers of this information in this analytics space. So let's go a little bit more detail into the 5 steps that I've got listed here. Now, the first thing that we're going to do is we need to go and create a model. Now, the model gives me an hierarchical structure. It provides me this asset or KPI context model that is abstracted from the data sources. So if I look at the volume produced for the day or for the shift, I don't care if it comes from the MES database, the historian database, it's normalized. So when everybody in the organization looks at this model, they know exactly what the KPI is that they need to look at. They don't need to care where that KPI is actually coming from a source. Now, very important to the model is that we also provide what we call context to the data. Now, the simplest form of context that we do apply to it is the context of time. So what is my total for the day? What is my total for a shift? Is a day 6 to 6? Is the day midnight to midnight? So all of this is getting context from the Flow calendars, and we can have multiple calendars providing time context to our data to turn it into information. That's the first step, is to build out this model and provide the time context to that model. When you're happy with that, then we can actually go and connect to a whole bunch of different data sources. Now, we classify these data sources in 3 classes. First class is our more real-time data that we get from sensors, could be from an MQTT broker or via OPC UA, and Flow can go and buffer that data to perform a calculation or an aggregation on top of that. The second type of class of data source that we can connect to is our historians or our time series data. This could be the ignition tag historian, it could be a canary historian, OSI pi, influx, etc. And we use this time series data obviously to pull it in from this historical source to also go and aggregate and transform the data. We never ever replicate the data that sits in these. We literally just pull it to perform the transformation on the tags that sits in these historians. Third type of class is what we call our transactional or relational databases. Examples of these could be your ERP system. Maybe there's some cost information that you want to work into your KPI, data marts, LIMS systems, MES systems, anything that can provide context to the data to give it a little bit more meaning when we try and make our decisions. And very importantly, there's a data source that you need to have when looking at this, and that's the human aspect. We need to still have the capability where people tells us the information to provide even more context to the data, even perhaps to correct some of the information or to classify a downtime event to the actual reason why it was down. So all of this data can now form into the flow model to provide even more additional context to the data. All right, now, when we connect it to these data sources, how do we go and transform the data to actually make the data into a meaningful piece of information or a meaningful KPI that I can now make my decisions on? Well, we go and transform that data. I'm going to move a little bit more into the nuts and bolts of how we do that. So let's take a tag. Let's take a tag from a historian, typical TVQ, timestamp value, quality, that we will then pull from this historian. Now, what if I want to maybe multiply this with data that comes from a SQL database? Well, I can go and write a query that can go and get the data out of that SQL database. And again, that query will provide me with a TVQ, timestamp value and quality. We call these tags inside of Flow. And what we actually do with these tags when I want to use it in a calculation is we normalize the points. All right, so we will do a point normalization on this. That will allow me to do zero loss row-based calculations based on this data. And some of the examples of that would be to filter out bad quality. If you don't want bad quality from your historian to influence your result, I can filter outside of a band, or I can filter based on the state. Let's say I only want to totalize a certain KPI when my piece of machine or asset is actually active. And I can use calculator tags to do this. Now, just like we can provide context of time to our model, we can also go and provide context based on potentially an event detection or event frame. So I can now use these tags and I can go and create an event based on the conditions when I need to start and when I need to stop this event. And I can associate a whole bunch of different attributes to this event as well. So think about a downtime event. Think about a batching process or the steps that it goes through in a batch, or even a machine state. And I would like to know what was the batch number while I was producing a certain batch and what was the total product that was actually manufactured within that batch. We will use these event frames as additional context to the tags. Now I can take these tags and I can go and either use the raw tag as well as the calculator tags, and I can now go and do what we call period normalization on top of this. So this is what we will do if I would like to know what was the total for the day or for the shift. I would take the result of my tag calculation. I would then go and aggregate it for the time period, let's say time weighted average to give me the total product produced. And then this data becomes a little bit more transactional like. So I've got a transaction for total product for the hour. Now these what we call a measure, and these can be our typical KPIs that we look at. We can look at production KPIs, usages, how much water or electricity was utilized in my batching process as an example. Equipment efficiency, revenue, cost, and we can even do a little bit of projections and forecasts on this information to show you where you're going to end up at the end of the shift potentially. I can also go and overlay the event context on top of this period. So I know exactly for a specific batch what was the actual product that was manufactured and how much of that was done inside of the current period that I'm looking at. So do this event context on top of the data. as well. All right, let's just step a little bit back here. I know this was a lot to digest, so let's look at this a little bit more practical type of example. So let's take a lot away there and let's just focus on how do I create these calculator tags, or how do I do this point normalization on top of the data. All right, so for my first example, I'm actually not going to do a query to a MySQL database. I'm going to have two historians. So I'm going to have another tag in my historian. The one tag in my historian, as you can see, I've got a little filling machine application here. And the one tag in my historian is going to tell me what is the state engine of the filling machine. Am I busy in the production run? Is I bidding with setup? So am I changing over to a new product? Am I busy in CIP or cleaning progress? And what I would like to know is, I've got another tag in a different historian that tells me what is my energy demand. So at the end of the day, I'm looking for a KPI that's going to tell me, hey, what is my energy per state? So I want to see if I can identify maybe when I'm doing a CIP, or maybe when the piece of equipment is idle, that I'm actually losing energy or losing cost based on the energy consumption of this device. So let's just do that. Let's just quickly create these calculated tags within Flow. All right, so I'm going to switch over to the Flow configuration environment. So this is the product itself. This is a little client that we use to create the model. So you can see here, I've got my little model here of my filling machine. I've got the total throughput, so how many good and bad production did this filling machine deliver. I've got a downtime event here to check the downtimes, the events frames as well. But one thing that I don't have yet is the utility. So I've got my little folder structure in my model for the utilities, but I haven't created any KPIs based off that. All right, on the right hand side here, I've got my different data source connections. So you can see I've connected to a Canary historian, I'm connected to the Ignition historian here. That will bring me the tags as it's been historized inside of that historian that I can utilize. And I've got this separate historian that actually stores the state engine of the historian as well. So let's have a look at that. I'm going to double click on this. It's going to browse the tags in that historian. Remember, as I said, we do not replicate this data, so we pull it directly from it. So this is the state engine. A little bit of how this works is if it's in state 0, it's in a stop state. When it's in state 10, it's pretty busy with the setup state. Then it's in the production state there when it's equal to 20. These little blips here is downtime events that happen on the filling line. And then the last state there, state 30, is our CIP process. Now, if I look at my Ignition tag historian, I do have the energy demand for this as well. So I'm going to drag this at the bottom here, and I can see what my energy demand is here. So if I zoom in here, I want to do two things. I want to detect what is the energy demand when I'm in this setup phase. So when I'm in state 10, what is the total energy that I'm utilized there? And then lastly, when I'm in CIP mode, that's state 30, I want to know what the energy usage is there. All right, so what I'm going to do is I'm going to extend my model here a bit. I'm going to create a metric, and the metric that I'm going to create here is going to be filler 1's energy. I can't spell this morning. Energy cost. Cool. So that's the KPI. I want to know what is the cost of my filling machine based on these different states that I've got. I'm going to do two things. I'm going to take the raw tags from the historian. I'm going to drag that across. So this is my first tag. So this is my source, and this is the source tag for my power that's been historized. But I also need that additional source telling me what the state is. So I'm going to go back to the second historian. I'm going to take the state tag here, and I'm going to add this in as well. This is going to be my source tag for the state that I'm currently in. All right, so this is the raw tags. If I open this up, you'll notice that it will give me the data as it is historized. Again, we do not duplicate this. This is just a view into these data sources. But what I want to actually do now is create a calculator tag, right? So I want to filter out the states that I'm not interested in. So I'm going to take the power, I'm going to drag it onto this little calculator icon here, and this is got my energy when I am in setup state, and I'm going to replicate that, and I'm going to duplicate this, and this is going to be the energy when I'm in my CIP state. So I'm creating 2 calculator tags based on that information. Open this guy up. So this is the setup state. I'm going to add the tag from my additional source, which is the state tag, into this as well. And now I can go and create a little calculation here. So I know that if I'm in setup, which is state equals 10, I would like to return the amount of power that I used, else I would just like to return null. I don't want to use that value in my aggregates. So this is just a little inline if statement showing me that. Obviously I can go and change my unit of measure here. This is going to be kilowatt hours that I get back, and let's validate this, and now I can see what this is going to do for me. So I refresh the data here, no data there. I'm not in the setup state. There's a little bit of data in the setup state as well. So it seems that calculation has worked. Let's quickly finalize the CIP one. Exactly the same process. I'm going to drag in the state here, and I'm going to say if the state is in state 30, then please return the value of the power, else just return null. Validate the calc, and let's close this guy up. Cool. Let's see if it worked. Let's drag in the setup state here into this tag viewer that we've got, and there we go. Now you can clearly see that I'm only using this blue portion here for this initial setup state. That's the only part that I am interested in. So technically what I've done is I've created a calculation based off 2 different historians, and I'm filtering out based on a state. Okay, so if we go back to the slide here, that's exactly what I've done. I've used my tag calculations to actually filter it out based on a state. Right, let's take this a step further. Let's do what we call a period normalization on top of this data. So what I would like to do is I would like to take those tag calculations, and I want to now slice it up into periods, into hours. I want to know what was my hourly usage when I'm in the CIP state. And I'm going to go and create those calculations as well. Now, what do I want to do with this? What is the KPIs that I'm actually interested in? Well, think about this. If I can get the cost of what it cost me per unit of energy, then I can actually go and create a KPI that's going to tell me what did it cost. What did this machine cost me when I'm in CIP or in idle state or setup state? And I can actually project this potentially into the future, and I can see what it's going to do at the end of the day, how much energy can I suspect to be paying based on a little bit of a projection or a forecast. All right, so let's do that. All right, I'm back in the flow configuration environment. I'm just going to close the raw data editor here, and I've got another data source here, which is my schedules and rates database that comes from Microsoft SQL data source. In here, I've got the actual cost per energy unit, and I'm going to utilize that to obviously see what the actual cost of my energy usage is. So what I'm going to do is I'm going to create a new metric here. This is going to be my cost per energy unit, and I'm going to drag in this tag in here as well. All right, so this is my base rate. I'm just going to call that my base rate of electricity. And now what I'm going to do is I'm going to actually create this period normalized measure for the hour. So I'm going to drag that onto the hourly icon, and this is now going to give me an hourly rate. That being in cents, I would like to change this to actually be dollars. And I'm just going to do a little bit of a scaling factor to change the cents into dollars there. Do a time-weighted average on that. That will then give me the cost of kilowatts per hour in dollars. I'm then going to take my setup state. I'm also going to create a period of that. This is going to be my hourly energy usage per state. And let's deploy this guy out as well. All right. Now what I can actually do here is I can go and create a cost calculation. So I'm going to take the hourly rate. I'm going to call this my cost. And I'm going to go and change this to be dollars. And now literally I can take my kilowatts multiplied by my hourly rate, and that should then give me a rate per hourly kilowatt usage. Right, so the engine is going to do its thing. It's going to run through this, and we'll see what the costs per energy unit is as soon as the engine ran through these calculations here. Okay, let's give it some time. There we go. So there's our cost for that initial state. Now I would like to project this into the future. So I'm going to work out an average of this 24 moving average that I can then use to project forward. But there's these null values here that you need to work with. All right. So I'm very quickly going to go and create a moving average calculation. So this is going to be my cost. This is going to be my moving average. I'm going to plot that nicely to create a nice model of that. And all that I'm going to do here is I'm actually going to clear out the editor, and I'm going to say, you know what, I want this for a range, and I want it over 24 periods so that I can work out the moving average. Now, I don't want the nulls to influence the statistical average, so I'm going to change the nulls to zeros in this. So I'm going to do a select on the values. This is a lambda expression based on C# notation. So I'm just going to say, okay, the element in this, which is the value, let's check if that has a value inside of it. If it does have a value, then just return the element. Else return a 0 instead of a null. And then let's do the average of that. So that's now statistical average on the time weighted. On statistical average on the cost, looking at a 24-hour period. All right, so if we look at this and we refresh, then this will go and calculate, and we've got a nice time weighted average for a 24-hour period. Now what I can do with this is I can do a progressive roll-up, so I can do what is the shift to date or the day to date of this. Let's do that and deploy that so long so the engine can do its thing. But very importantly, I can now project this into the future. So I'm going to take my calc, drag it onto the calculator again, and this is going to be my projected usage. Whoa, if I can spell. Alright, so that's my projected guy, and I'm going to do 24 hours into the future, and I'm going to now clear out the expression editor here, and then just look at a previous period, which is going to be 24 hours back. So I've got that 24-hour moving average projected forward. Deploy this out, and now I have a projected guy going in here. Let's just see how that works. The engine is going to pick it up. It's going to do its thing. There's the projected values. We can see here that's all the way to the end of tomorrow, the 4th. All right, and let's just do a projected of that as well. So shift to date and a day to date, so you can see where we're going to end up from a day to date perspective. Right, very importantly, I need to be able to project this guy as well, right? So just before I forget, I need to project the day to date into the future as well. So let's do that, and the engine will then project this guy into the future. There we go. Now I've already created a chart for this, just to show you guys. I'm using the KPIs in my model just to say what I want to show on the chart. So this is our flow server front end. If I go to the cost estimation graphic part here, I can see this is where I'm currently at from a day-to-day perspective, and then at the end I'm going to probably end up with $6 worth of energy utilized there. I've created another dashboard just as an example from my production side as well, so I can track my production tracking. So here you can see again same kind of concepts but based on the throughput, and I've projected that into the future as well. So that's just a little bit of the graphical capability that we've got. All right, so I took the tag calculations, I've created these periods, then obviously to complete the circle we can then visualize it. I showed you guys a little bit of the visualization capability that we have, a lot more capable than the little part that I've showed you just now in the visualization. But a very big thing for us is to be able to bridge this data out. Now there's numerous ways that we can bridge it. We can bridge it back to potentially a data mart. We can potentially bridge it back to the historian. We can even put it back on the MQTT broker for a real-time sensor to actually consume that. We do have messaging where we can push it out to our messaging system, and we can also go and create tiering. If it's a multi-organization, we can tier one flow with another. But we also have a REST API that makes this available to be consumed by machine learning tools or BI tools or SCADAs. So all of this can be utilized through our REST API. Now, very quickly, let's look at two of the consumers that we've got. All right, so I'm back in the configuration tool. I'm just going to close this configuration here. Now, I've created my actual throughput here as an example. So here I've got daily total of product that I'm manufacturing. And you can see here that I can go and specify integration. And I've got two consumers currently set up. One is a data mart, which is a SQL database. The other is an MQTT broker. All right, so I'm going to drag my consumer, literally going to drag that into the integration section here. And I'm going to drag my MQTT broker here as well. Being a database, I've got full control of the query or this that I need to adhere to from the schema of the source. I've already created a query here that I'm just going to copy and paste for my schema of my data mart, and I'm going to plonk it in there for us. I'm going to deploy this out, and then it's going to go. I'm also going to deploy out the MQTT broker. Let me just clear out my table. So let me show you that there's nothing in this table, and let's start pushing. So I'm pushing over MQTT. I'm also pushing into the data mart. I do have a little MQTT broker here as well that I'm going to connect to, and let's see that data coming in. There we go. We can see our message comes up in the topic and following my nice model, and I can see my daily bottles there. So there I can see my actual production value on my MQTT broker, and if I execute this in my SQL, there we go, populated my data mart there as well. We also have a module for ignition. So very quickly, I just want to show you guys that if I go to the configuration here, obviously you need to log into the gateway, and right at the bottom I've got my flow analytics provider that I can configure, and what that will allow me to do is just browse it as a tag within Ignition. So on my chart here, I am able to go and browse for the tag. So if I click on that, you'll notice that it does pick up as a historical provider, and you can just see now all the KPIs that I've configured available for me to just pick and be able to show that in an Ignition screen as well. All right, so that's how we would use the REST API to actually go and consume that data out. What do we push out? Well, we push out the tags as well as the events and measures that we store. So all of that is stored in or can be passed through with the API. Right. Some of our clients, Flow is quite a generic tool. As you can see here, being used in food and bev and in manufacturing and mining. So very versatile in the type of industrial information challenges that we can solve for our clients. Thank you very much. From a next step perspective, I would encourage you guys to, if you want to, let us know if we can introduce the product to potentially a partner or an end client of yours. We would like to understand the KPI and challenges that you guys have in your processes to get this information going, and let's see if we can help defining some business objectives and prove the value of having this one contextualized data source. So I would like to action you guys to reach out to us, schedule a meeting that we can potentially talk of how Flow, the analytics hub, can solve some real problems for your clients based on their information need. With that, I say thank you for listening to today's session. I hope you guys have a great rest of your day.